What if Earth and Mars collided? Just think about that for a moment. Two entire worlds, our home and the red planet, on a collision course. It sounds like something straight out of a science fiction blockbuster, doesn't it? But in the grand cosmic theater, such dramatic events, while exceedingly rare for established planets, are part of the universe's story. Our solar system is a dynamic place, full of motion and energy. Planets are not just static points of light in the sky, they are colossal spheres of rock and gas, each following its own path around our star, the Sun. It's a delicate dance, this orbital ballet. Earth, our vibrant blue marble, teems with life. It has vast oceans, a protective atmosphere, and a comfortable temperature range, all thanks to its specific distance from the Sun and its geological activity. Mars, on the other hand, is a colder, dustier world. It's smaller than Earth, with a thin atmosphere and evidence of ancient water now long gone from its surface. It's a place of stark, rusty beauty, holding clues to planetary evolution and perhaps even past or future microbial life. These two neighbors have coexisted for billions of years, each tracing its distinct elliptical journey without incident, a testament to the stability of gravitational forces. Currently, their orbits are well separated and stable. Earth circles the Sun at an average distance of about 150 million kilometers, while Mars orbits further out, averaging around 228 million kilometers. There's a significant gap between them, a cosmic safety buffer. For a collision to occur, something would have to go catastrophically wrong with this ordered arrangement. The laws of physics that govern planetary motion are precise. Planets generally like to stick to their paths, influenced primarily by the Sun's immense gravity. But the universe is not an entirely predictable place over truly vast timescales, or when external factors come into play. So how could such an improbable cosmic catastrophe even begin to unfold? It's not something that would happen overnight or even over centuries. We're talking about fundamental changes to the very architecture of our solar system. The chances are infinitesimally small in any human timescale or even geological ones. But the universe has been around for about 13.8 billion years. And in that immense expanse of time, the improbable can sometimes become a statistical possibility, however remote. We must consider the forces that could, theoretically, nudge these worlds from their serene paths towards a destructive rendezvous. Planetary orbits are essentially a continuous state of falling. Imagine throwing a ball. It curves downwards and hits the ground. Now imagine throwing it so fast that as it curves downwards, the Earth's surface curves away from it at the same rate. That ball is now in orbit. Planets are constantly falling towards the Sun, but their sideways motion, their tangential velocity, is so great that they continuously miss it, tracing an elliptical path instead. This balance is governed by gravity, primarily the Sun's, but also the subtle gravitational tugs from other planets. It's a finely tuned system, a gravitational dance perfected over billions of years. For Earth and Mars to collide, their orbits would need to intersect. This is a radical departure from their current nearly circular and well-spaced paths. What could cause such a drastic change? One extreme possibility is a massive rogue object, perhaps a wandering black hole or a rogue planet ejected from another star system, passing through our solar system. Such an intruder, if large enough and passing close enough to Mars or Earth, could gravitationally perturb their orbits significantly. It's like a cosmic billiard ball scattering the others. This is a highly dramatic but also highly unlikely scenario, a true wildcard in the celestial game. Another more subtle but still incredibly improbable mechanism involves long-term chaotic interactions. Over millions or billions of years, the slight gravitational nudges from other planets, particularly giants like Jupiter, can slowly alter planetary orbits. While our solar system is remarkably stable, it's not perfectly so forever. Complex mathematical models suggest that, over vast timescales, there's a tiny chance for orbits to become eccentric enough to cross. Think of it as a slow, almost imperceptible drift that, given enough time and the right or wrong alignment of planetary influences, could lead to an intersection. This isn't a sudden jolt, but a slow descent into orbital chaos. If such a destabilization were to occur, Mars's orbit would likely become more elliptical, stretching inwards towards the Sun and outwards into the asteroid belt. If that inward stretch crossed Earth's path, a collision would become a terrifying possibility. The approach wouldn't be instantaneous. We'd see Mars growing larger and brighter in our sky over years, then months, then days. Calculations would become frantic. The red planet, once a distant neighbor, would transform into an ominous harbinger of doom, its rusty glow filling more and more of our vision as it hurtled towards us on its altered, fatal trajectory. Imagine the final moments. Mars, a world half the diameter of Earth, fills a significant portion of our sky, its reddish hue no longer a distant curiosity but a terrifying, rapidly expanding disk. The gravitational forces leading up to the impact would be immense. Earth's tides would surge to unimaginable heights, kilometers high, sweeping across continents. The crust of both planets would begin to fracture and buckle under the immense tidal stresses even before they touched. The atmosphere would be superheated by friction and compression as Mars plowed into Earth's protective blanket, a terrifying prelude to the main event. The collision itself would be an event of almost unimaginable violence. It would dwarf any asteroid impact, any nuclear explosion by many orders of magnitude. The energy released would be colossal, far exceeding the energy that holds planets together. Both Earth and Mars would effectively cease to exist as distinct planetary bodies in that instant. A significant portion of both planets' mantles and crusts would be instantly vaporized and ejected into space at incredible speeds. The cores of the two planets might merge, or fragments of them might scatter. It's a collision that redefines the very meaning of destruction on a planetary scale. For Earth, the immediate consequences would be absolute annihilation of its surface environment. The oceans would flash into steam, instantly becoming part of a superheated, rock vapor atmosphere. The entire crust would be shattered, and vast quantities of molten rock or magma would be exposed and flung outwards. Any life on Earth, from the smallest microbe to the largest whale, would be extinguished in moments. There would be no place to hide, no sanctuary from this cosmic cataclysm. The very ground beneath our feet would become a sea of fire, and then a cloud of incandescent debris. Mars, being the smaller body, would fare no better. It would be utterly obliterated. It would essentially be absorbed by the larger Earth, or rather by the roiling mass of superheated material that was once Earth and Mars. The impact would generate shock waves reverberating through the combined planetary material, melting rock and sending colossal plumes of debris thousands, even millions of kilometers into space. What was once two distinct planets would become a rapidly expanding cloud of incandescent gas, dust and molten rock, a new, terrifying nebula in our solar system, glowing with the fury of its creation. In the aftermath of such an Earth-Mars collision, the debris cloud wouldn't just dissipate. Gravity would get to work. Much of this ejected material, a mixture of vaporized rock from both planets, would eventually begin to coalesce. It could form a new, larger planet over millions of years, a super-Earth born from the ashes of two worlds. This new body would be incredibly hot initially, a molten sphere slowly cooling over geological timescales. It might eventually develop a new atmosphere and crust, but it would be a vastly different world from either Earth or Mars, its composition a hybrid of the two. Alternatively, depending on the specifics of the impact, the angle, the speed, the debris might form a spectacular ring system around the newly merged planetary core, perhaps more massive and brilliant than Saturn's. Or, it could form one or more new moons. Our own moon is thought to have formed from a similar, though less equal, giant impact between early Earth and a Mars-sized protoplanet called Theia. So, a new larger moon, or multiple moons, orbiting the fused remnant is a distinct possibility. This would drastically alter the night sky and tidal forces on the new, reformed planet, assuming it eventually cooled enough to have liquid oceans. The effects wouldn't be confined to just the Earth-Mars system. The sudden change in mass distribution, and the gravitational shock waves from the collision, could subtly perturb the orbits of other planets in the solar system. Venus, Mercury, and even the gas giants might experience slight shifts in their paths. The asteroid belt could also be affected, potentially sending more asteroids careening into the inner solar system. The entire architecture of our cosmic neighborhood would bear the scars of this cataclysmic event for eons to come, a permanent alteration to the solar system's familiar layout. Reflecting on such a scenario, however improbable, teaches us profound lessons. It underscores the dynamic and sometimes violent nature of the cosmos. Planets are not eternal, they can be unmade. It highlights the incredible forces at play in the universe, forces that shaped our solar system and continue to sculpt it. And perhaps most importantly, it gives us a deeper appreciation for the relative stability and sanctuary our Earth currently provides. Our planet is a precious, perhaps unique haven in the vastness of space, and understanding the cosmic dangers, however remote, reinforces the need to cherish and protect it. The universe is full of wonders but also potential hazards,